Hello and welcome. In today's video, Sneer and myself will look at how the Exadata dedicated cloud platform integrates with OCI's IPv6 dual stack functionality. The Exadata Cloud dedicated infrastructure supports the IPv6 and IPv4 dual stack networking model provided by OCI. This allows both protocols to operate simultaneously on the client and backup subnets. So to enable a VM cluster on the Exadata that supports IPv6, we need to create a virtual cloud networking and subnets with IPv6 capabilities. Once this networking is in place, we can then provision the Exadata VM cluster using these subnets. The minimum version requirements is Exadata system software at 24.1.4, and for the database and grid infrastructure side, 19.26 for 19C or 23.7 for 26AI. Now let's have a look at it in action with a short demo. The first thing we need to do is create the underlying networking ready for the Exadata VM cluster. If we go to networking and create a VCN using the Start VCN wizard within OCI, we'll select a create VCN from internet connectivity. With internet connectivity, we'll go through the wizard. We provide basic information such as the VCN name, which compartment we wish this to be in, the IPv4 CIDR block we wish to use for the VCN, and we'll also select the enable IPv6 radio switch. We then get the choice with IPv6 prefixes to either add our own or use Oracle allocated ones, which is what we've selected here. In the wizard, we can configure public and private subnet. We already have this for the IPv4 version, but what we can do is add another IP address type. We can select the IPv6 prefix, and then we can select the value for our IPv6 networking. Again, we will do the same within the wizard. The wizard allows you to create a public and a private subnet to get you started. And again, for the private subnet, we will hit the another IP address type button and select the IPv6 prefix. We can now hit the next button to review our selections before we create. After reviewing our choices, we can hit create. We can see that one problem occurred, and this is because NAT gateways are not applicable for IPv6 root rules. This is fine because this is just part of the wizard, and we won't need this for our demonstration on the Exadata dedicated platform. If we view our VCN, we can see it's created. We can see under routing, we have a route table for the private subnet, and we have a default route table. There are currently no root rules for the private, so we'll add root rules. And we'll select a service gateway and all services in that network. And we're doing this for the IPv4 stack. We can see that the rules have already been put in for the public subnet by the wizard, and that was just to point to the internet gateway. So with our subnets, we have a private and public subnet that was created by the wizard, and we can see that it has an IPv4 CIDR block and also an IPv6 value as well. Our next step is to create a VM cluster on the Exadata using this network. We go to Oracle Databases, select Exadata Database on dedicated infrastructure, and we'll create a cluster. So we can create any display name we want. We'll call it VM Cluster IPv6, give it a cluster name, select the model, select the cluster type. Here we can leave the defaults, the number of OCPUs, the amount of memory. This is fine just for this demo. And Exadata Dedicated allows you to change these values after provisioning anyway. We'll use 19C as our grid infrastructure version. We'll upload a key which allows us to connect to the VMs that have been created. When it comes to networking, we will select the IPv6 VCM we have just selected, and then the public subnet for the client and the private subnet for the backup network. This will then provision the VM cluster on the Exadata infrastructure. This process has been speeded up for the sake of the video. We can see now that it's completed and the cluster has created successfully. We can see no error messages were created during the provisioning. If we go back to the details page and scroll down, what we can see under the networking section is the backup subnet that's being used, the client subnet that's being used, but also notice that the scan IP address has both IPv4 and IPv6 addresses, but still has the same, just one scan DNS name. If we go to the Virtual Machines tab, we can see each of the virtual machines that have been created, as well as having an IPv4 address, also has an IPv6 address. If we open a terminal and connect to one of the cluster's VMs, so this is node 1, and we do an IP address, and we look, we can see that bond ETH0, which is the client network, has both IPv4 and, as you would expect, IPv6 entries to it, as does bond ETH1, which is the backup network, again has both IPv4 and IPv6 addresses. If we look at the listener status, so I'll select the environment for the correct database and do a listener status, and we'll see that the listener status also has IPv6 entries as well as IP4 ones. We can look up the scan address, do an NS lookup, and we can see that it provides entries for both IPv4 and IPv6. And we can also do an NS lookup on one of the nodes to the clusters, and we can see that one of the nodes to the cluster also has entries for both IPv4 and IPv6. Now let's take a look at creating a database on the VM cluster we've just created. And this is no real difference from how you would create a database on any Exadata dedicated infrastructure cluster. You give it a database name, database unique name, we'll select 19C. We can either create a new database home, or we can basically use an existing one. Give it passwords. We can select whether to have automatic backups created or not, and we'll hit create. This will now provision the database sitting on this cluster. We can see the job has been accepted, and the create database home is 10% complete at this point. This process has been speeded up for the sake of the video. If we go back to work requests, we can see that the create database had run and is now completed. Again, that has been speeded up for the sake of the video. and we can see that it is running and its PDB is available. We can see the connection strings for it, and we can see, because we selected automatic backups, the database is now starting to back up, an initial backup. So we can see it says backup in progress, backing up to the autonomous recovery service. That concludes our demo for using IPv6 with Exadata Dedicated. We hope you enjoyed it. Thank you for watching.